Finding life beyond Earth is no longer a dream. It's a discovery that will likely be made during our lifetime. And it will change everything. We've been here for more than 36 years, at the forefront of a quest that many consider science fiction.
Mars is the closest planet where we might find the possibilities of alien life.
We are home to over 100 explorer scientists.
It just takes your breath away.
Our purpose is singular.
It's kind of best to understand what you have in your own backyard as you're looking up into the cosmos.
To understand the origins and prevalence of life in the universe.
What we are doing is to try to understand, are we alone in the solar system?
Why do we pursue our mission? Because the discovery of life beyond Earth will lay the framework for humanity's next steps to the stars.
We are trying to understand why we even exist.
We are the SETI Institute.
Welcome. Welcome everyone to the 2026 Drake Awards. My name is Molly Bentley. I am the executive producer and co-host of the radio show and podcast Big Picture Science.
And I'm Seth Shostak, senior astronomer at the... I'll sell my car to pay you guys off later. Also co-host of Big Picture Science and senior astronomer, as I say, of the SETI Institute.
I'm just going to keep this here. After more than 20 years of being produced by the SETI Institute, Big Picture Science spread its wings last year to become an independent production. But during those many years with the Institute, we had the pleasure of interviewing stellar SETI Institute scientists, including astronomer Frank Drake. And Seth, you knew Frank well, didn't you?
I think many of the people in the audience here knew Frank well. I met him in 1972, I believe it was. He came down to Charlottesville, Virginia, where I was working at the National, yes, fellow Virginian, working at the National Radio Astronomy Observatory. And he gave a colloquium. I have to say, Molly, the thing that impressed me most, not so much the talk, it was great, but we expected that. What I didn't expect was that Frank was such a nice guy. And ever after, I always referred to Frank Drake as the world's last nice guy.
Too, like whenever you wanted to go and talk to him, his office was close to yours.
Frank was very accessible. His office, I mean, you know, do we have time for about 40 anecdotes? His office was about 30 feet down the hall from mine for many, many years. And I would occasionally wander into his office. And, you know, whatever he was doing, he was always doing something. Of course, everybody is. But he would look up and he'd turn to me, he would smile and he'd say, "Hi, Seth, what's on your mind?" And I asked him about that. I said, "Frank, where did you develop this equanimity?" And, you know, I thought it was dealing with the public or something. And he said, "No, students."
Well, we want to acknowledge the venue that we are in, the venerable Computer History Museum. Anyone here for the first time at the museum? Okay. Well, we hope you have a chance to see its exhibits. This is where the evolutionary arc of the information age is on display. And Seth, we have recorded a few shows at the Computer History Museum. In fact, we recorded one right here on this stage. And we recorded a show many years ago, and it was about the fears that we had at that time about the impact of ever more powerful computers. And it was an episode called "Do Computers Bite?" B-Y-T-E. Yes, but now it's a subject that seems quaint in the AI age.
What I know, Molly, is that they immediately take umbrage whenever you use a pun. I don't understand that. That's always considered the lowest form of humor, where I think it's the highest form of humor. Anyhow.
Well, if they're taking umbrage, there'll be a lot of umbrage taking tonight.
Yeah. Well, indeed.
Oh.
Yeah,
go ahead, please.
It is one of my favorite museums. I mean, I live in Mountain View, so it's not very far for me to come down here. But they have things like the Babbage difference engine. And many of you in the audience will know what that is. But that's an analog version of the earliest computers, right? The most important thing that probably the 20th century will be remembered for is the development of the computer. Not the world wars and all that stuff, the development of the computer. And you can learn about it here.
We'd like to acknowledge right off the bat and thank our sponsors, which are going to appear on a slide in just a moment, and give a special thanks to Amaresh, Kollipara, the chair of the board of directors at the SETI Institute. Looks like you have a lot of fans here.
Tonight is about, well, celebrating curiosity, discovery, and addressing fundamental questions about the human story. How did it begin? And not just life, but what about the evolution of intelligence? Getting life started might not be so difficult. Getting intelligence started might be. There are people in the audience who can address that. Laurie Marino comes to mind, but you're going to hear from her later. So if such intelligence could have evolved here, I mean, the whole point is, if it could have happened here, it may have happened elsewhere. In fact, if it didn't happen elsewhere, this is a miracle. And I know that many of you think you're a miracle because your parents told you that all your life, but it might not be true. So,
scientists don't usually use the M word when they talk about scientific discoveries. The miracle word. Well, anyway, many scientists here. So some of the questions that Seth posed, how did life begin, and is there life elsewhere in the universe? Many scientists here tonight don't stop at just posing these questions. They have dedicated their research lives to try to answer them. But there are also prosaic questions out there, such as how will this evening unfold? And these are the questions that we can answer for you tonight.
Yeah, and indeed, do we want to know, I mean, why do we want to find life elsewhere, right? It's just to answer these questions again, to know how singular we are, or are we not at all singular, but merely commonplace.
So we will honor 3 scientists tonight and premiere a documentary short. The ceremony concludes at 9 p.m. and it's followed by an opportunity for photos and some mingling in the lobby. And in a moment, you'll hear about a man, a plan, and his equation. And Seth, I think that the Big Picture Science did an episode about every factor, every part of the Drake equation over the years.
We have. There's 7 terms in the Drake equation. For those of you who don't know the Drake equation, you should really bone up on it because you'll be able to impress the neighbors if you can, cite it. But some of those terms we know, other terms we don't know. But I think that, the reason that Frank posed the questions inherent in the Drake equation, the reason he came up with the Drake equation, as he told us routinely, was because, he was asked to give a talk about the search for life in space, because Frank did the first SETI experiment back in 1960, where he used an antenna, 85-foot diameter antenna in Greenbank, West Virginia, pointed at a couple of nearby stars, called it Project Ozma, because he was a fan of Frank Bound. That was the beginning of SETI.
And Frank Drake didn't simply ask the question of whether or not we were alone in the universe. He was bold enough to conduct the very first SETI experiment to try to answer it.
He was. I said I wasn't going to give you too many of these anecdotes about Frank, but I'll give one to give you, this one's clean, to give you some idea what it was like working with Frank, which it was honestly an honor. We went on a lot of trips together, mostly eclipse expeditions. Well, expedition's too big a word. But we would go to places where a total solar eclipse was going to happen, and we would give talks, and there were a bunch of people that traveled with us. And Frank, what do I have to say? Frank never referred to the Drake equation. He was explaining the Drake equation in these talks, but he never, ever called it the Drake equation. He just said this formula. And I think that says a lot about Frank. He was a very, very modest guy. Very bright, obviously, but very modest as well. And that endeared him to me, I have to say.
And with that, we hope that you enjoy this short video about Frank Drake.
This array of antennas, situated in the Cascade Mountains of Northern California, is not tracing the interstellar gas of our galaxy. It's not imaging objects like pulsars, quasars, or the neighborhoods of black holes. It's searching for evidence of intelligent extraterrestrials, aliens. This endeavor is known as SETI, the Search for Extraterrestrial Intelligence. It is a daring experiment that could forever alter humanity's view of itself. An experiment to use modern technology to find other galactic inhabitants was first attempted by a soft-spoken astronomer named Frank Drake. Born in Chicago at the start of the Great Depression, Drake was interested in chemistry and electronics. He enrolled at Cornell University and was part of a Navy officer training program. After graduating, Drake was put in charge of electronics aboard a Navy cruiser, the USS Albany. In 1955, he entered Harvard as a radio astronomy grad student. After receiving his degree, the young Frank Drake joined the newly minted National Radio Astronomy Observatory in the soft hills of West Virginia. The observatory had just purchased an off-the-shelf radio antenna sporting an 85-foot dish, and Drake, the new guy in town, was encouraged to think of experiments befitting this instrument. What followed was a 2-month observing program he christened Project Ozma after the fictional Princess Oz in Frank Baum's book. In an experiment that discomfited some astronomers, Drake used the antenna to look for radio signals coming from the directions of 2 nearby stars, places that could conceivably house planets with intelligent beings. He wasn't studying natural processes, but looking for emissions launched into space by an extraterrestrial society. He didn't find any alien signals, but Project Ozma had generated a tidal wave of interest. A year later, Drake was encouraged by the National Academy of Sciences to convene a small meeting of a dozen scientists to weigh the odds that we could find aliens by eavesdropping on radio transmissions. The meeting was held in the fall of 1961 at the observatory where Drake had done Project Ozma. As agenda for the meeting, he wrote a simple equation on a blackboard that would estimate the number of on-the-air societies that exist in our galaxy. This agenda, now known as the Drake equation, has been called the second most famous equation in science. Thus began the modern era of SETI. Drake had planted a seed that has sprouted into several signal searches in progress today. These efforts are constrained not by a lack of technical expertise or astronomical knowledge, but by a shortage of funding. SETI is run on monies donated by a handful of interested individuals.
We will need to search through literally at least millions of stars to give us a good chance of finding a signal from another civilization.
SETI experiments have not yet found proof of extraterrestrials, but a small number of scientists are continuing the search with new observation programs and the development of new receiving equipment. By 2035, these experiments will have reconnoitered about 1 million planetary systems, an impressive sample. So it's conceivable that Drake's audacious experiment will soon pay off, that we will learn that humans are not the only intelligent species in the cosmos, that we share the universe with others.
Hello, good evening. How is everyone tonight? All right. My name is Amaresh Kollipara. I'm the chair of the board here at the SETI Institute, and it is my honor to welcome all of you for the 2026 edition of the Drake Awards. We're gonna have a fun night tonight. You can clap, that's okay. We have a wonderful program planned for tonight, and as I look out into the audience, I'm noticing that we have quite a high-caliber audience tonight. Quite impressive. We have astronauts, we have investors, we have CEOs, we have award-winning scientists, of course, and we have movie producers. I see that some of you also brought well-dressed and good-looking plus ones, so thank you for that contribution. But I want to single out a few people in the audience tonight. I see one, Jill Tarter. Hi, Jill. How are you doing? It is always wonderful to be in your presence. As everyone knows, Jill is the co-founder of the SETI Institute and trailblazer extraordinaire. We have Nadia Drake in the audience. Hi, Nadia. How are you doing? So Nadia is an unparalleled science journalist, and also I heard that she's a credentialized Drake as well. So we just saw a video about her father, and we hold this gala in his honor tonight. In addition to those wonderful luminaries, we also have 3 astronauts in the group tonight. Yeah. Right in front of me, Sarah Sabri. How are you doing? Thanks for joining us. So Sarah not only is the first Egyptian to travel to space, she's also the first woman from the African continent to go to space. And at this table over here, we have Dr. Cyan Proctor. How are you, Cyan? So Cyan was the first African-American woman who piloted a spacecraft, and that happens to be SpaceX's Dragon spacecraft that she flew for her Inspiration 4 mission. So trailblazer indeed. Well done. And we actually have another astronaut as well, JD Russell. Hey, JD. How are you doing, my friend? So JD is not only an astronaut, but he's also an investor who is essentially catalyzing with his investment fund the growth of the new space industry. So thank you for that, JD. And this guy, by the way, is such a freaking astronaut that he's been to space twice, and he's about to go a 3rd time. So it's a little bit of a show-off, dude, but that's okay. The reason I bring up the astronauts is I wanted to introduce a concept called the overview effect, and most of you may have heard this before. So these 3 astronauts have experienced something that I call a cognitive shift. It's basically when humans observe Earth from space and view it from that vantage point. The overview effect, or the cognitive shift, is basically what they saw is the Earth essentially in the darkness of space, devoid of any national borders, any country borders. But Earth there, in its fragility, in its complete beauty. And it's essentially an awe-inspiring moment. I've never experienced it. I hope to go to space one day. Maybe JD can buy me a ticket. But it's basically a transformational moment for folks that have experienced this. They come back from their trip infused with a new sense of interconnectedness with the human species, delineated and not delineated by any constructs that we tend to divide ourselves with. So this is actually a thing that's been talked about since the Apollo era. So Apollo astronauts talked about it. In fact, recently the Artemis II astronauts came back, which you probably saw, and they mentioned it as well, this cognitive shift. But having said that, it's a wonderful thing, but only 800 people on the planet have experienced it. There's been only 800 people that have gone to space, that's all. 1/10,000,000th of all humanity. And that's not that big. So I'm gonna posit today, what if there's another cognitive shift that could take place? What if there's a cognitive shift similar to the overview effect that could take place that doesn't impact 800, but impacts all 8 billion of us? Well, let's fast forward to the topic of tonight. I would posit that within the lifetime of the vast majority of people in this room, we will, with some degree of scientific certainty, answer the question, are we alone? With a negative. I'm sorry, with a positive, of course. So I'm glad you're not sleeping. All right. So imagine that day. Imagine that day. Imagine when that scientific discovery or series of discoveries lead us to that scientific certainty, if you will. I would call that a species-level cognitive shift, a species-level overview effect, if you will. It won't affect just 800 people. It'll affect every single human on the planet, all 8 billion. I'm not trying to paint a sci-fi future for all of you. I actually think this is not only plausible, but actually likely. Likely, once again, within the time frame or the lifespans of most of the people in this room. In the next 2 decades, possibly. But why do I say that? So I believe we're on this, we're at the beginning of an inflection point for all things SETI. The beginning of an inflection point. A confluence of events are happening over the next few years. One thing you probably all heard about was there's several space telescopes bringing back amazing amounts of data for humanity to analyze. Our wonderful ATA, our Allen Telescope Array in Northern California, whose team is here, Andrew, Vishal, and others, thanks you for your contributions, my friends. There they are. The ATA is firing on all cylinders and increasing our capability as time goes on. In addition to that, we're in a new era that's defined by AI. So we're utilizing AI analytics to actually analyze mountains of data, something that was not available just a few years ago. Partnering with companies like NVIDIA to accelerate the understanding of the science research that we're doing. In addition to that, you probably all heard about the commercial space industry as well. So one of the largest, let me rephrase that, the largest IPO in the history of humanity will occur this year with SpaceX. $2 trillion valuation, that's gonna raise a lot of other commercial companies along the way as well. We at the SETI Institute are partnering with some of those companies to advance our science research as well. So take all of these confluence of events together, and what I'm trying to paint a picture of for you is that we are on the precipice of a wonderful uptick, an inflection point, that over the next few years, the amount of science that is being done by the team at the SETI Institute and all of our affiliates will dwarf the previous 40. And in that moment, the likelihood of us having a human civilization cognitive effect, a cognitive shift, much like the overview effect that I talked about earlier, is plausible, and some would say likely. So imagine that day. Imagine when that happens. It would transform the understanding of most major human subjects. I would say it would actually completely transform every fiber of the fabric of what it means to be human, or the human condition. Every subject you can think of, from the natural sciences, biology, chemistry, physics, astronomy, astrophysics, will be transformed for the better. Even subjects that you wouldn't necessarily think about would be transformed as well. Religion, spirituality, sociology, anthropology, the arts, linguistics. Imagine that transformative moment impacting every possible human on the planet within possibly the lifetime of the vast majority of people in this room. An 8 billion person cognitive shift. So I'll leave you with this thought. I was gonna talk for about an hour and a half, but I'm keeping you from your entrees, so let's speed this up. Using a similar construct as the overview effect, there possibly could be another term for this future that I'm describing, and I call it the Great Recognition. And I'll describe why. So, recognition, because it is a recognition of what our intuition already tells us is most likely, that we are not alone in the universe. But recognition is actually more dynamic, in that it's a recognition of us, kind of pointing inwards as well. So the recognition is that this is not a cognitive shift for 800 people only, but for 8 billion. This cognitive shift, the Great Recognition, is not bound by borders, not bound by ethnicities, not bound by socioeconomic status. It's every human on the planet would be potentially impacted by it. And that's one of many reasons why we do what we do. We ask the big questions. Our wonderful team of world-renowned scientists work tirelessly in their specific disciplines to answer wonderful questions like this. And it is an honor to be part of the organization, and it's an honor to have all of you here as well with us tonight. Before we break for entrees, think about this one last question I'll leave you with. Most of you know that our mission at the Institute is to lead humanity's quest to understand the origins and the prevalence of life and intelligence in the universe. It's not only that too, but it's also to make sure every human on the planet knows about it. We're working on it. Over the next few years, as I described, we're going to go through this inflection point tick. Each and every one of you will have a front row seat to that effort. Once again, the great recognition is upon us. You all have front row seats. So as you break for entrees now, we're going to take you won't hear from anyone for about 45 minutes, so enjoy your entrees and enjoy your desserts. Molly and Seth will restart the program after dessert. But as we break for that, talk amongst your tables. Think about this great recognition, what it means for you, your spheres of influence. What do you think it means for humanity? So with that parting thought, thank you once again. Great to have all of you with us. Enjoy dinner.
I've known this next guy ever since he was brought to the Institute as its new president and CEO, Bill Diamond. Bill Diamond has done something truly remarkable at the SETI Institute. In particular, he stabilized the funding, which means, and that was a bit, I know it's not very interesting to you, particularly if you're into the science, but the facts are that's what made the science possible. And the Institute was always on the precipice of disappearing for lack of money. Most of you may know, maybe not all, that all SETI research in this country is funded privately, okay? A lot of people think it's NASA, but it hasn't been a NASA program since the very early 1990s. Anyhow, that's what Bill Diamond did, and he's going to be our next speaker. So if we could welcome to the lectern here, Bill Diamond.
All right, good evening, everybody. How are we doing? All right. So wonderful to have you all here tonight, and of course, it's an honor to be introduced by somebody like Seth. You know, so Frank Drake was described as, you know, the last nice guy, and you know, Seth is one of the more incredible guys, and I'm the not nice guy. That's my job. It's also my job to be a little more concise than our chairman of the board, so I'm going to try and do that resolve. But he was inspiring and set the stage for tonight. But I also want to point out something that we also all love about Seth, and those of you who are fans of big picture science know this very well. He's the only broadcast personality in the country that comes with an FCC warning about allergies to puns. So, you know, we have to put that at the beginning of each show. But anyway, he's been, you know, he and Molly have had this amazing program that lives on its own now, Big Picture Science, that if you don't know about, you should listen to. It's inspiring and fun. But tonight, we're going to talk about science and celebrate it. So I want to welcome all of you. I want to welcome the members of the board of directors of the SETI Institute, members of our council of advisors. There are lots of friends here, donors and supporters, colleagues. We have scientists here from the Institute. So there's too many actually to name, but I do want you to take time to get to know the people associated with the Institute that may be at your table, or you may have had a chance to talk to outside earlier. But on behalf of the SETI Institute, thank you for joining us tonight. We celebrate the 2026 Drake Awards and honor a remarkable group of individuals whose work expands our understanding of life, intelligence, and our place in the cosmos. This evening is, of course, a celebration of achievement, We're proud to recognize Lori Marino as this year's Drake Award recipient. For her pioneering work exploring animal intelligence, consciousness, and communication. Her research challenges us to think more deeply about the nature of minds beyond our own, and in so doing, broadens our perspectives on what it means to be human. Tonight, we also celebrate and honor one of our own scientists, Dr. Matti Tiscareno. With the Carl Sagan Center's Director's Award, recognizing not only scientific excellence, but the curiosity, dedication, and collaborative spirit that drive discovery forward every day. And perhaps most importantly, we celebrate the next generation of explorers and innovators by recognizing 3 outstanding undergraduate interns, Maria, Matti, and Blayne. Their work last summer demonstrated extraordinary promise and passion for science. Their presence here reminds us that discovery is not a finished story. It's a continuing human journey carried forward by new minds with new questions and new ideas. So at a time when the value of science is too often questioned, gatherings like this matter deeply. They remind us that science is more than data, laboratories, telescopes. It's more than just profoundly human endeavor. Science and basic research are the foundation on which all the technology that surrounds us in this extraordinary valley, and indeed in this extraordinary building, is built on the foundation of science. And that is all too readily forgotten, and we should not forget that at all. Whether we're studying distant worlds or searching for signs of life beyond Earth, whether we're exploring the intelligence of other species on our own planet, or mentoring young scientists just beginning their careers, we're united by a shared sense of wonder and a shared commitment to discovery and all that it enables. And none of this happens alone. To all of you, our friends, supporters, colleagues, partners, donors, and members of this community, thank you. Your presence here tonight reflects your belief in the importance of science, exploration, education, and the free pursuit of knowledge. Institutions like the SETI Institute can only thrive because there are people like you who believe that curiosity and discovery are worthy of support and celebration. So tonight, let us celebrate not only our own honorees, but the larger spirit of inquiry they represent. Let us celebrate those who ask difficult questions, pursue evidence wherever it leads, and dedicate themselves to expanding humanity's understanding of life and intelligence in the universe. So tonight you can meet all kinds of interesting people, and as I said before, there's too many here to name, but I do want to name one in particular. And I do this with a very specific purpose in mind. How many of you have ever been nominees for an Oscar? Nobody, okay. Well, imagine if you were a nominee for an Oscar, what would be your biggest fear if you won? You would get up on stage and forget to mention somebody. That's what I did last night at our VIP event at the SETI Institute, which was great fun, and I was introducing all kinds of people. But the most important person in the room, I failed to introduce. I'm not going to make that mistake again tonight. You've heard the name once before, but without this individual, none of us would be here tonight. And I would actually like everybody to stand up and recognize our own pioneering radio astronomer, pioneering engineer, one of the co-founders of the SETI Institute, the inspiration for the character played by Jodie Foster, Ellie Arroway, in the movie Contact, and that, of course, is Dr. Jill Tarter. So believe me when I say I won't make that mistake again. But it's so wonderful to have Jill here tonight. And of course, it's pretty cool to have Frank's daughter, Nadia, here with us tonight again. And again, too many others to name. But anyway, I again thank all of you for being here, because your presence and your support is what helps make our work possible. So we're very deeply indebted to you. Thank you for being here with us this evening. Please enjoy the celebration and the congratulation of all of tonight's honorees. And I'll leave you with my own final thought and quote, which is: the most remarkable thing we may discover about life in the universe is that it's not remarkable at all. Okay, with that, I turn it back over to Seth and Molly. Thank you very much.
Thank you, Bill. And maybe a round of applause for that fabulous jacket. The Carl Sagan Center's Director Award is our first award of the evening. It is given to a SETI Institute scientist who has demonstrated outstanding achievement in their field. And the award honors Carl, the astronomer and former SETI Institute board member, whose leadership and public outreach on behalf of science continues to inspire scientists and the public alike. And we'd like to thank the award sponsors for this award, Elizabeth Varghese and Matthew Vidon. Please give them a round of applause. Thank you very much. And Seth, did you meet Carl Sagan?
Yes. Many times, actually. In fact, I mean, not that anybody cares, but I almost took a job working for Carl Sagan. But he got sick, and 2 months later he was okay again. But in the meantime, I had been offered a job down in Charlottesville at the National Radio Astronomy Observatory, and as a Virginian, I decided I would take that job instead. Maybe a mistake, maybe the wrong exit on the Hollywood freeway, but that's what I did.
Well, to present this award, please welcome one of my favorite people at the Institute, Nathalie Cabrol, the director of the Carl Sagan Center for the Study of Life in the Universe.
Good evening, everybody. I'm Nathalie Cabrol, the Chief Scientist of the SETI Institute, and it is my great pleasure tonight to present the 2026 CSC Directors Award. This award recognizes individuals whose work advances fields connected to the Drake equation, while also demonstrating a strong commitment to education, mentorship, and public engagement. It honors scientists who not only expand knowledge, but also help inspire the next generation of explorers. And this year's awardee is Dr. Matti Tiscareno. Yeah. Matt is a planetary scientist whose work has profoundly shaped our understanding of Saturn's rings and the small moons embedded within them. Through his contribution to the Cassini mission, he helped reveal the extraordinary dynamical complexity of planetary ring systems, including the discovery and characterization of propeller moons hidden within Saturn's rings. His research has shown us that even seemingly delicate structures can preserve the signatures of powerful physical processes. Matt's works contributed to one of the most important discoveries in planetary science of the last decades by helping demonstrate that Enceladus harbors a global ocean between the icy crust, a finding that fundamentally reshaped our understanding of ocean worlds and their potential habitability. Matt leads the Ring Moon System node of NASA's Planetary Data System at the SETI Institute, continuing a legacy of stewardship and scientific service that benefits the entire planetary science community. But beyond this scientific achievement, Matt has shown exceptional dedication to mentoring students and young researchers. Since 2017, he has directed the SETI Institute RU program, helping guide and inspire the next generation of scientists. Under Cynthia Phillips before him, and now Matt, this program has gained such a reputation and visibility that it's almost become more difficult to get selected than into Harvard. Imagine 600 applicants last year alone. And we can certainly be proud of our alumni. Since 2020, 3 of them have been recipients of the Hurry Prize, one of the most prestigious prizes in planetary sciences for young researchers. Tell me about fostering talent and nurturing passions. And Matt was also one of the first members of the Division for Planetary Sciences, Professional, Cultural, and Climate Subcommittee, which worked tirelessly on aiming to understand barriers faced by underrepresented communities in planetary science. As you can see, Matt combines scientific rigor with curiosity, generosity, and a remarkable ability to communicate the beauty and complexity of planetary systems to broader audiences, and it's only fit that his commitment and service be recognized today. So Matt, on behalf of the Carl Sagan Science Council, your colleagues, and the SETI Institute, it is my honor and privilege to present you tonight with the 2026 CSC Director's Award. Congratulations, and thank you for all what you do.
Thank you, Nathalie and Simon. I am very grateful to receive this honor. It is a privilege to work at such an illustrious place as the SETI Institute, and it's encouraging to be told through this token that my work is appreciated. I want to thank my mentors, starting with Dr. Joe Burns of Cornell University. In the 11 years that I worked with Joe, he consistently exemplified for me the integrated scientist who pursues excellence in his work with a generous spirit for the community around him. I've also learned a great deal from each of my other scientific mentors, Dr. Renu Malhotra, Dr. Mike Brown, Dr. Phil Nicholson, Dr. Carolyn Porco, and Dr. Paul Geisler. Dr. Mark Showalter, who is a fellow of the SETI Institute, recruited me to come here and to succeed him as manager of the PDS Ring Moon Systems node. Along the way, Mark has been an amazing mentor, example, and colleague. I am both grateful for and daunted by the challenge of stewarding the data archiving enterprise that he built together with Dr. Mitch Gordon. Mark and Mitch, thank you for that legacy and for your continuing partnership. Thank you also to the terrific RMS data archiving team here at SETI. I am so proud of the way we have come together, learned from each other, and built ourselves into a very capable team. I look forward to serving the science community together with you for years to come. I also want to recognize Dr. Chrissy Ritchie, who has only recently come to the SETI Institute, but has long been a mentor and example to me in taking action to care for the community, supporting the marginalized, and reaching out to dialogue with neighbors, all while maintaining excellence in our work as scientists. Thank you, Chrissy. I'm also thankful for Pamela Harmon, who recently retired as the SETI Institute's Director of Education. Pamela has been a sounding board, a voice of wisdom, and a source of accountability for me in my decade of running the REU's summer internship program. Thank you, Pamela. The REU program is a massive community effort, and I am thankful to so many people. Our science mentors give of their time to train the next generation of scientists and STEM professionals, while nearly everybody on the Institute's staff has at least some role in hosting our students and helping to give them a positive summer experience. Thank you all. In my remaining time, I'd like to reflect on 2 principles that have guided my work at the SETI Institute: excellence and community. I believe the Institute itself values and pursues these principles, and it's my desire and honor to be part of contributing to that culture. First, excellence. The whole reason we are here is because the work we do is amazing. For me, it's been learning new things about Saturn's rings and other aspects of the solar system, puzzling out the details of how they work, and sharing the exciting results. More recently, my focus has shifted towards work that enables others to pursue research, which honestly I find just as exciting. Whichever it is, we pursue excellence at the SETI Institute because discovery is a source of joy, an important part of what we humans were created to do. But to do it well, we must do it together, and that means community. Studies show that a caring workplace and a diverse workplace is a more effective workplace. But productivity aside, this is also just the right thing to do and the right way to be. I believe that every human has inherent value and dignity. And I also believe that the only way for humans to be healthy is to embed ourselves into networks and communities in which we both give and receive, in which we actively care about each other's flourishing. Since I arrived here more than a decade ago, I have found the SETI Institute to be a place where people live this way. And it has been easy and pleasant for me to be intentional about living this way in my own day-to-day life at work. I haven't always been successful. Sometimes I make mistakes, do the wrong thing, maybe even hurt people despite my intentions. But for me, this way of life means setting out to practice generosity, to respect everyone regardless of perceived status, and to widely include people in community activities. It also means inviting others to share their experiences and concerns and listening carefully when they do. It means, with fear and trembling, trying to act wisely and kindly in difficult situations, to stand with anyone who is wrongly marginalized, and not to be satisfied until every single person from whatever background is fully able to contribute to and benefit from the community we are building. I'll conclude by thanking my own community, my wife and children who always support and inspire me, my parents who taught and formed me and the rest of my family. Also for me, 4-H and church have been places where I connect with neighbors and pour into their lives and receive the same in return. I hope that you have places where you do that. Thank you to those who selected me for this award, and thanks to all of you who make the SETI Institute a great place to work, a community of excellence. Thank you.
Let's give another round of applause to celebrate the work of planetary scientist Matt Tiscareno and his, not just a ringing endorsement, but a Saturn's ringing endorsement of the value of community. Thank you for that, Matt.
All right, Molly, I just want to talk a little bit again about the person who really deserved the Drake Award but never got it, namely Frank D. Drake. As I say, Frank was a colleague of mine. Well, I mean...
Sorry, as the journalist in the room, there are a few of them here. He did win the award. He won the first one.
Really? He didn't tell me about it?
Yeah.
Well,
That's how it's got its name.
well, Frank is very modest. I mean, he was very modest. And maybe that's why he didn't say anything about it. I have to say, I mean, traveling with Frank, as I had the good fortune to be able to do on those eclipse trips, was always quite interesting. He would never tell anybody who he was, right? But sometimes it would get out. And I can't help but remember a circumstance in South Africa, actually. We were in a taxi going to some, abandoned field somewhere where it was going to be, where we could watch the total eclipse of the sun. Good song title, that. Anyhow, and at some point, the taxi driver asked the name of the guy sitting in the back of the car. And I said, well, that's Frank Drake. And he said, what do you mean, the Frank Drake? And we nearly all died because he just swiveled the steering wheel and nearly went off the road. He was so impressed. Frank's story is another example, by the way, of the way that great science is motivated by great questions, right? And also seeing a way to answer those questions. And that's what Frank did. He did more than just, come up with this equation, which, as I may have mentioned earlier, was really the agenda for a meeting that was held in Green Bank, West Virginia in 1961. But he figured out that if you wanted to be able to prove that there were aliens out there, intelligent aliens, maybe the way to do it was to try and eavesdrop on their signaling. And he did the first SETI experiment, Project Ozma, thereafter. Anyhow, what we're trying to do here is encourage the next generation of innovative scientists. So the SETI Institute, together with its partners, particularly the Berkeley SETI Research Center, have created an endowment called the SETI Forward Fund that will support and encourage the next generation of SETI scientists. SETI Forward will increase pathways, possible pathways, for undergraduates interested in careers pursuing SETI research. And as I think all of you who have gone to college, and that's surely 10% of you or more, know that, you know, whatever inspiration you get when you're in your late teens is something that stays with you forever. So this is a very important initiative.
From there, thank you. SETI Forward supports undergraduates who are already doing extraordinary work in SETI and astrobiology. And to introduce this year's SETI Forward recipients, please welcome the founder and chairperson of the program and founding member, I have to take an extra breath here, and vice chair of the SETI Institute's Council of Advisors, Levy.
Hello, welcome to the 7th annual SETI Forward presentation. Thank you all for being here, demonstrating your continuing support of SETI and for tonight's award recipients. A very big thank you to the SETI Institute team for their annual work putting on this event and for keeping things fresh each year. The Computer History Museum is a wonderful choice and I love the nostalgia here. Just last week, I was at a friend's house and we came across a Commodore PET computer. And if you don't know it, you don't know it. It was complete with the tape drive and up to 8K of RAM. So in my career, I've gone from working with punch cards now to LLM. SETI Forward recognizes undergraduate interns taking part in projects related to the search for life, whether technological or biological. We annually recognize students who demonstrated a desire to pursue related fields as their career choice, and whose mentors recognize them for pay-it-forward type of traits. Each year, I notice that the applicants more frequently represent cross-field research with varied interests and skills. I see applications from new institutions for both undergraduate studies and internship opportunities. The shared desire to find life outside of Earth's biosphere draws us together. As Matt talked about community, we all wait to celebrate the discovery of that elusive signal, the observed evidence of a technological civilization, or the discovery of past or present biology outside of Earth. I appreciate all the people that have helped over the years to enable the SETI Forward program and to recognize the achievements of the students of SETI. It's because of all of you that SETI and the overall search for life continues on, carrying out the legacy of Frank Drake and so many others. The search is a generational endeavor. SETI Forward's intent is to help continue the search forward to future generations, to create ambassadors who demonstrate the amazing work taking place in the search and who will eventually answer the questions that we don't even know yet ask, to prove our shared assumption that N is greater than 1 and that Earth is not the only habitat for life. Our first recipient tonight is Maria Calderon-Marrero. Maria's undergraduate career and internship are from Cornell University. Her intern project focused on researching microbial life in El Tatio, a hydrothermal field in Chile's Atacama Desert in one of the closest Earth analogs to ancient Mars. High in the Andes Mountains at 4,300 meters, it is the driest desert in the world and home to the largest geyser field in the southern hemisphere. She collected microbial mat and water samples along temperature gradients from boiling pools to cooler outflow channels to investigate how microbes survive in these extreme conditions. Maria plans to pursue a PhD as a microbial astrobiologist and hopes to contribute to space missions that target environments most likely to preserve evidence of life and to study microbial survival and biosignature preservation in Earth analog environments and help translate those findings into life detection strategies for Mars, Europa, and beyond. Maria?
Good evening, everyone, and thank you to the SETI Institute again for this incredible honor. This summer was a dream come true for me, and I'm so excited to share some of the work that I did. As mentioned, this past summer, I conducted fieldwork at El Tatio, Chile, in the Atacama Desert, and one of the closest Mars analogs environments on Earth. For me, it was also my first time conducting fieldwork ever, which meant jumping straight into sampling boiling geysers, all while trying to battle elevation sickness as well. What made this experience so memorable was not just the amazing desert, but the life thriving despite it all. Walking around, there were no plants, no cacti, the elevation was just too high for that. But despite it all, around these amazing boiling geysers were the most beautiful and bright orange, green, pink, and red microbial mats. All across these beautiful geysers, following the path of the waters, entire communities of life living despite it all. At the different geysers, I collected microbial and water samples at different points away from the geyser to understand how they adapt to their local thermal environment and leave their mark and provide clues for how we may search for life on other planets, and particularly Mars. In the lab, I've been culturing these microbes, and just last week, I finished up DNA extractions to prepare for DNA sequencing so we can identify the microbes that are in this area and find reliable biosignatures that we may use in the search for life. We also plan to understand how these microbial communities are interacting with their environment, their geochemistry, and the geology to paint a bigger picture of what these environments and how these microbes are surviving. I would also like to advertise if anyone is attending the Astrobiology Science Conference next week, I will also be presenting this work. This award has also helped me present this work at the AGU conference this past December as well. I would also like to thank my mentors in the Cornell University McNair program, specifically my mentor, Carolina Munoz-Saez, and thank you to everyone here for helping support students like me with big dreams in searching for life beyond Earth. I'm also happy to announce that this award comes at an exciting time, as I plan to be graduating from Cornell next week, and I will be pursuing my PhD at Georgetown this fall. During my PhD at Georgetown, I will plan to continue doing this work, studying life in extreme environments to identify reliable and robust biosignatures that we can use in the search for life beyond Earth. Thank you very much.
Our next recipient is Matti Weiss. Matti attended Queens College in New York and interned with the Berkeley SETI Research Center working on the Beam SETI project. Matti created a Python package so SETI researchers can better understand what's really inside the telescope's field of view. Instead of looking at just a handful of stars, these tools combine both real catalogs based on telescope data and statistical models to count all the stars and galaxies that fall within the beam. Using this information to estimate how powerful a signal from an extraterrestrial civilization would need to be for us to detect it, and how common such transmitters might be based on current non-detections. Matti describes SETI as one of the rare scientific endeavors that invites creativity alongside precision, bridging art and design with cutting-edge technology to tackle some of humanity's most profound existential questions. Are we alone? And if not, how might we recognize another form of intelligence responsibly? Matti?
Thanks for that introduction, Lou. My work focuses on codes I developed called Beam SETI, which stands for Background Extragalactic and Milky Way SETI, because it helps us study not just the target center of the beam, but all of the background objects inside and beyond our galaxy, that could also host a detectable technosignature. So in terms of the motivation for my work, traditionally, SETI searches focused on one target at a time. That would be the bright star you see in the image, all the way on the left. But each telescope pointing actually contains a much larger population of stars and galaxies around that target in an area. This slide shows one example field of this area with center star HIP 101382, where Gaia DR3, our real star catalog, identifies 429 stars within the GPTL beam area. That's the red circle you see. While SynthPop, a simulated star model, returns over 124,000 stars in the same region. This immense difference shows why counting everything in the beam matters. When we look across the full beam area, we greatly expand the survey volume and get a better estimate of what a telescope observation can really tell us. For the paper I'm working on with Ben Jacobson Bell at Breakthrough Listen throughout this past year, the result of beam SETI is a transmitter rate, or TR, which is likelihood of detection measure, on the y-axis of the plot, versus EIRP, or signal power, on the x-axis of the plot. And this compares Ben's nearby star sample with Carmen Choza's nearby galaxy sample, another former Breakthrough Listen intern. Ben's nearby star sample reaches lower EIRP, so more on the left side of the plot, and lower transmitter rate values, so further down on the plot, while Carmen's galaxy sample is stronger, or lower on the plot as well, at the higher end, or right side of the plot, and together they show how cataloged and modeled galactic and extragalactic bycatch complement each other. This research also points towards future work and refines star per galaxy assumptions and extinction corrections, while linking the same completeness ideas to exoplanet catalogs and models, so we can further ask how many potentially habitable systems might be out there. I'm very grateful to the SETI Institute for the SETI Forward Award and for inviting me here, and to my mentors and collaborators at Breakthrough Listen for helping make this work possible. Thank you.
Our final recipient is Blayne Griffin. Something all three recipients share is the view that SETI is not just one discipline. Granted, it's not a statistical sampling, but the applications for SETI Forward do show a shift where more of the applicants are early adopters to cross-discipline studies. This observation is not limited to scientific disciplines, as other studies, such as philosophy and art, also add to the search by providing other perspectives and ways of thinking of the universe and life. If we are to pick up a signal, decoding that signal is just the beginning. Understanding the message requires other skills. Blayne received the 2025 REU Award of Excellence and is now employed full-time by the SETI Institute. After attending Lyon College for only 3 years, he graduated with a BS in chemistry as an honors fellow. He then attended the University of Central Arkansas, where in just 3 semesters, he graduated with a second BS in physics. As an intern, his project was an observation of Breakthrough Listen's Exotica catalog with the ATA under the guidance of Dr. Sophia Sheik. This catalog assumes our own ignorance and postulates about life as we don't know it. Contained within the catalog are stars, exoplanets, galaxies, nebula, quasars, neutron stars, interstellar media, asteroids, and more. Blayne?
Hello. Thank you all for having me. Yes, as Lou mentioned, thank you. I was an intern at the SETI Institute last summer, and my work was under Dr. Sophia Sheikh, and most of our SETI searches have been for life-light humans, so Earth-like exoplanets and sun-like stars, which is only natural, we're only human. So my work, my catalog was written by Breakthrough Listen, and the purpose of the catalog is to assume our own biases and our own ignorances and try to remove them from the equation. We already have extremophiles on Earth, so why can't the same be true elsewhere? So my work kind of assumes that path and looks in places that no one ever has before. So my catalog has targets ranging from in orbit of Earth, like within the solar system, to within the Milky Way, to far outside the Milky Way. I have quite literally one of everything, which it's pretty fun. There we go, there's a clicker. So as Lou said, I am currently working full-time at the SETI Institute. I work at the Hat Creek Radio Observatory, and this is my view every morning as I go to work, and it's amazing. And I work with this wonderful piece of equipment performing this search. And it reminds me of why I got into science and into space studies in the first place. And we have such human and earthly problems here. There's politics, there's wars, there's funding crises. But whenever you look into space, all of that kind of fades away. And we're reminded of where we are as humans and where aliens might be. So that's why I do what I do, and why I don't think it's hyperbole to say that being an RU student and now working full-time, I think it did change my life. 2 years ago, I didn't know what I really wanted to do. I knew what I enjoyed doing. I love hands-on research. I love science accessibility. I love early science education. I know that I love those things, but I didn't know what I wanted to do for a career. And then I went to the RU. I worked under Sophia Sheikh. I worked with the other students. And I realized that I want to do what I do right now. I want to continue this project. I want to do more like it. I want to bring it to more people like me. And I am very thankful to the SETI Institute, Dr. Tiscareno for accepting me to the RU, Sophia Sheikh for accepting me as her student not once but twice, because she's now my boss. My advisors at my home university, especially Dr. Lust, Dr. Jeremy Lust, he's the whole reason I got into radio astronomy in the first place. Of course, my mom is here with me right now, kind of the whole reason I'm doing any of this. And really just thank all of you. Thank you for being here and for being interested in not only science, but asking where we are in the universe and where we might be in a few years. So thank you all.
Thank you, Lou, and also another round of applause for the students and for the hope that they represent for the future of science and its continuation. Well, we have arrived at the centerpiece of the evening. The SETI Institute's Drake Award celebrates exemplary contributions to SETI or astrobiology through scientific research and space exploration. The award honors astronomer Frank Drake, whose Drake equation, as we mentioned, is a probabilistic formula to estimate the likelihood of life in the universe and the evolution of technological civilizations.
This honor is given at the discretion of the Board of Directors of the SETI Institute based on nominations from its Science Advisory Board. The honoree is presented a cash award and a trophy. Hope they all have, a fireplace above which they can display the trophy and point it out to any visitors they get to their homes. And is invited, the honoree is also invited to describe their research at a public ceremony like this one. And I have to say, I was in attendance when the first award was initially presented to Frank Drake himself in 2001. I don't know how many of you remember 2001, but lamentably, I do.
The movie or the year? Maybe both. Tonight, we are proud to present the Drake Award to neuroscience and evolutionary biologist Dr. Lori Marino. Now, Seth, I know that Seth has a few stories about Lori, but as the producer of Big Picture Science, I am indebted to her for always agreeing to be interviewed for the program about animal intelligence, whether it was whale or dolphin or the evolution of intelligence. She was on many episodes. Some of them include an episode called The Drake Equation. There was an episode called You Animal. And my favorite, perhaps, though, was the episode in which Lori described reproductive behavior, and it was titled Sex and the SETI. Those are real titles.
Well, I have to say, I met Lori actually at an astrobiology conference in Santa Cruz, and she always impressed me with her expertise, and of course the fact that she was very easy to talk to. She was very accessible. Not something you can say for all scientists, I regret to say, but anyhow, that was the case. Lori was trying to suss out universal aspects of intelligence, and she was doing what scientists often do, finding an analogy for something they don't understand in something they do understand. Now here's a trivial and often, well, not often, but a trivial and fairly inaccurate example of such an analogy. When people talk about, atoms, people don't know much about atoms, they say, oh, they're like little solar systems. Well, superficially they are, although the physics is completely different. But nonetheless, it helps to visualize what you're talking about when you have that analogy. Anyhow, this idea that you could use an analogy to try and suss out what an alien intelligence might be like led people who knew about animals, cetaceans, like dolphins, including Lori, of course, to say, look, if we can understand their evolution on the basis of their behavior, that might give us some insight into what alien intelligence might be like. And in fact, for quite a while, when I first arrived at the Institute, many of the scientists there were wearing a little pin that signified that they were members of the Order of the Dolphin, which I assume was a take on the Order of the Garter, but they didn't wear garters. They did wear these little dolphin pins.
Before we bring Lori to the stage, she and some people who know her work describe the significance of her many years of research in this brief documentary by Emmy Award-winning filmmaker Kelly Kowalski.
Once upon a tide, in a stellar spiral, far, far away, a young human thought to herself,
what is it like to be a member of another species?
Our human liked to converse with earthworms, construct hospitals for intrepid insects, and daydream about axolotl, tamarins, and tapirs. When the human grew, she worked in a lab that experimented on rats. Yes, we do have much to learn about this odd human species, but in our story, our human was different.
So I decided that I did not want to kill rats for a living. And for a few years, I did work on space adaptation syndrome.
While it was delightfully whirly assisting space humans from regurgitating their insides out, our human could not stop thinking about all the other Earth species, like the pink fairy armadillo, or the satanic leaf-tailed gecko, or the sarcastic fringehead. No need to worry, the fringe head lives in an ocean eons away. Right. So now our human decided to get her PhD in biopsychology and animal behavior. And then one day, she came across a book.
And in that book was a photo of a dolphin brain. And I thought, wow, that's a big brain and that's a different brain. And I've been hooked ever since.
Yes, Earth vertebrates don't get to enjoy the multi-sensational experience of having many minds, as do we. You see, billions of years before our human was born, single-celled organisms roamed early Earth, moving ions across membranes, electrochemically interacting with their environment. Fast forward a few 100 million years to multicellular life, which began restructuring and refining that ancient architecture of ionic flow, creating specialized neurons and nervous systems all over planet Earth. Now, if you go back to the Eocene epoch, a curious mammal shifted its lifestyle towards the ocean, evolving as the tides turn into a variety of aquatic, air-breathing carnivores.
There was a change in ocean temperature. It's a pretty extreme stressor.
And those that came out on the other side were the brainier species.
They probably went from being big, bad loners with teeth that would keep you up at night to socially complex beings who depended upon each other.
And for about 10 million years or so, cetaceans were the defining, big-brained inhabitants on planet Earth.
When you look at the fossil record, dolphins and whales have had their really big brains for a lot longer than we have.
And when our human measured the brain sizes of her hominid ancestors with those of cetaceans, she discovered that
up until about 1.5 million years ago, which is a blink of an eye in evolutionary terms, the brainiest animals on the planet were not hominids. It was dolphins and whales. So the human brain has to be understood in the context of being one variation on a theme that's as old as time itself. There's nothing special about the human brain.
Yes, indeed. Why on earth do they? But you see, brain size is only part of the evolutionary story. Brain architecture is critical, as is its complexity. Now, humans love to point out their extra crinkly outer layer of neocortex. And while the human neocortex is voluminous, the cetacean neocortex is extra crinkly.
They have pushed a lot of brain tissue into their cranium. And the orca has more neocortex for its brain size than we do. So they are more neocorticalized than we are.
Orcas, and most cetaceans, are cognitively sophisticated social creatures. They work together, they play together, they have families and friends. They celebrate births and mourn their dead.
And so it could be that social complexity is a driver of increased brain size and elaboration, and thus intelligence.
Yet cetacean brilliance was not always recognized by humans. That is, until our human revolutionized human thinking about cetacean thinking.
The mirror test is a test of self-awareness. When we look in the mirror, we know that's me.
Self-recognition is a rare capacity in the animal kingdom, and at the time of our humans' discovery, only great apes had shown self-awareness.
When we showed that dolphins recognize themselves in mirrors, that was the first time a non-primate could. That was a big deal because no one expected that.
Nor did they expect that the dolphins would, how shall I say?
That they wanted to see themselves in the mirror having sex. Those are on dolphin porno tapes. We didn't include that in the final paper, but it's pretty clear when you see it. It was so dolphin.
Right, back to the brain organ.
When you look at the two neocortices, the human and the dolphin, There are two different ways to process information, two different ways to be really highly intelligent. You don't have to do it the human way.
The rare capacity of mirror self-recognition is synthesized through the human's frontal lobe. The dolphin brain is designed different, and there's less of a frontal orbital lobe. Good question. How did they?
We don't know. It's probably not in their orbital lobe. They found another way for some pretty sophisticated cognitive stuff.
The back of the brain is where humans construct their visual reality. But that's not how dolphins see the world. Their visual and auditory perception is integrated up top.
You have vision and a second auditory region right next to each other, and we think it has to do with echolocation. When they echolocate, you hear this. And it's clicks, high-frequency clicks. Before they send out one click, they've processed the previous click. Think about how fast you have to be to do that.
A dolphin click travels a mile per second. Those clicks help them perceive their watery world at great distances, mapping everything from the inside out. And when our human and colleagues mapped the brains of dolphins, they revealed auditory connections to both the parietal and temporal lobes.
The nerves that take acoustic information up to the brain, they're huge. They've got all this myelin wrapped around them. And the more myelin, the faster the neural transmission. They are very quick thinkers, very fast.
Yes, human reality seems rather flat without fluid acoustic vision, but don't feel too sorry for them. Humans are known to pollute and overfish their oceans. They keep cetaceans captive for entertainment. And some of them even eat cetaceans. Well, that's where our human comes in.
You have to understand the implications of your own findings. The two dolphins who I worked with on the mirror study, like, okay, they're self-aware, look at where they're living. And I was also working with a chimpanzee named Clint, and I worked with other chimpanzees too, but I hung out a lot with Clint, and he's the kind of guy who you'd want to just go for a beer with, you know. He was a wonderful, wonderful person. And then one day I went into a lab at Yerkes, and then I opened a cupboard. In the cupboard on the shelf was a jar. And in the jar was a brain, and the label said Clint, and I never went back. And I decided that as a neuroscientist, somebody who studied these animals, not only could I not participate by studying them in captivity, but I had to do something to protect them, to advocate for them.
Not quite. Sadly for cetaceans, many countries still keep them in captivity.
In a dolphinarium, everything that makes life worth living for a dolphin and a whale is missing. They engage in all kinds of behavioral abnormalities indicative of brain damage and chronic stress. They're driven by the same feelings that we're driven by.
While the number of marine facilities has grown in some countries, others are restricting and phasing out cetacean captivity.
When I realized that the only way to bring an end to using these animals in marine parks was to create sanctuaries for them. And that's when I started the Whale Sanctuary Project. The French have gotten out of the business of dolphin and whale shows. We put in a proposal to bring Wiki and Keijo to come to our sanctuary. If it happens, it'll be huge.
Let's keep our tentacles crossed. Not quite yet.
I mean, look at how we treat other animals on this planet. Even the ones we know are highly intelligent and self-aware. And we know that they are thinking, feeling beings. We have to get over our own species. We have to get over the human brain and see it in the context of being just one brain of millions. But it will be up to us to open up our eyes to the notion that intelligence is ubiquitous on this planet. If we see humans as the only version of intelligence, we're not going to recognize it somewhere else.
The end. That's for another story time, silly. Now quiet a brain and don't let the crustaceans bite.
Good evening, everyone. I'm Dr. Lucian Walkowicz, and I'm the chair of the Science Advisory Board and the co-director of the Discovery Futures Lab here at the SETI Institute. Tonight, it's my great honor and privilege to introduce the person you've all been waiting for, who you've just heard just a little bit about, our 2026 Drake Award winner, Dr. Lori Marino. Dr. Marino's impressive reputation precedes her. A neuroscientist, her research has contributed groundbreaking insights not only into our understanding of the brain anatomy and cognition of marine mammals like dolphins and whales, but more broadly into self-awareness in other animals and what these animals' experiences teach us about the evolution of intelligence, both here on Earth and in the cosmos as part of SETI. As impactful as her many stellar academic achievements are, though, is Dr. Marino's commitment to following the implications of her research. Her science is situated not only on the one-way street of what animals can teach human beings about intelligence, but in what those findings mean for what we humans and how we humans relate to the 8 million other species here on this planet. Now, over my career in astrobiology, I've heard myself and my colleagues often express not only what we hope to discover through our research, but how we hope our discoveries change how we and other human beings, including people outside of the professional sciences, conceive of ourselves in the scope of the broader universe. We often express that we hope that the definitive discovery of life beyond Earth will bring people wonder or joy or a greater sense of connectedness, and you heard that in our welcoming comments from Amaresh earlier tonight, a cognitive shift. But Dr. Marino's research and career path demonstrates how following the science can transform our relationships to other forms of intelligent life in ways that are much deeper than just excitement. It was through her research on self-awareness in dolphins that her career expanded to include the ethical considerations of how humans study these amazing creatures, and led to her impactful advocacy at the intersection of science and law. Her work has contributed to landmark policy changes and major legal shifts to free our fellow intelligent Earthlings from captivity. Many times, I think efforts like Dr. Marino's to advocate for ethical, responsible science are unfairly framed as somehow preventing scientific progress. But her work demonstrates that being accountable to what our research means can also help us learn with the animals that we hope to learn from. It's because of Dr. Marino's work to release cetaceans into rich ocean environments that we will also discover new things about alien communication and cognition right here on our own planet. So without further ado, I give you this year's Drake Award winner, a scholar, a champion, and a trailblazing role model for responsible science, Dr. Lori Marino.
All right, so Lori, congratulations. We are so appreciative of your work and also appreciative of that beautiful film. It's what a wonderful story and beautifully captured and told by the sea creatures. We have this certificate for you of acknowledging your outstanding work and contributions to your field of this study of animal intelligence and maybe helping us understand a little bit more about what it means to be human. We have a medal for you as well. And thanks to Franklin Antonio and his endowment at the SETI Institute, thanks also to the financial supporters and donors of the SETI Institute. The SETI Institute is very pleased to give you, for the continuation of your work and your foundation, a $50,000 check, which we present to you tonight.
Wow. I want to start by thanking everyone for being here and saying that I appreciate everything that the SETI Institute has done and will continue to do. I'm especially honored to share this evening with my husband, Michael. And I want to thank the Institute and the Board of Trustees, Bill Diamond, Lucian, Walkowicz, and the SETI Science Advisory Board, Tom Dearda, Rebecca McDonald, Kelly Kowalski for that cute video. Also, I want to thank a couple of other people. I want to thank Chris Chiba, who was a great colleague from the early days of the Life in the Universe program. And special thanks to Catherine Denning. My friend and collaborator on many of the SETI and astrobiology programs that I've worked on throughout the years. I am particularly honored to receive this award in the name of Frank Drake, not only for his being a pioneering scientist, but for the human being that he was. In 1993, I was a graduate student studying dolphins and the evolution of intelligence. And I attended my first bioastronomy conference in Santa Cruz. I looked around, and there were people like Barney Oliver, Jill Tarter, Freeman Dyson. I must have looked like a deer in the headlights. Frank came right up to me to introduce himself. And I will always remember how warm and welcoming he was. He hugged me. And he said, "Don't worry, we don't bite." And I took that lesson with me throughout my life, especially as a teacher, because Frank showed me that I should always look through the eyes of the other person to make them feel comfortable. And in many ways, that is what I've tried to do my whole life, since I was a small girl. Look through the eyes of someone else. And in my case, someone who is a member of another species. A honeybee, an owl, a chimpanzee, a lizard, a dolphin. Tonight, I want to talk with you about what I've learned about intelligence on Earth through my own studies and what it means for SETI and astrobiology. In 1961, Frank Drake developed the Drake equation to organize our thinking about the probability of there being civilizations in our galaxy that would be capable of communicating with us. My work has focused on the Fi term in the equation, the fraction of life-bearing planets on which intelligent life emerges. For much of my graduate work and later, I've tried to answer a fundamental question, and that is, exactly how special are we in terms of the size and complexity of our brain? About 35 years ago, I went to the library one day. I opened up a book and happened upon a photo of a dolphin brain similar to this one. I was stunned. Although it had a different shape, a different neocortex, the outer covering of the brain involved in higher order cognition, and a different map, I realized I was looking at a brain that looked just as complex and elaborated as our own. And this made me realize that perhaps we need to take a second look at our long-standing assumption that we are the only highly intelligent species on the planet. So for my PhD, I compared the relative brain size of primates and of dolphins and whales over the past 50 million years. Here's a graph showing the relative brain size for some modern primates, including humans and dolphins. First, it shows that modern human brains are about 7 times larger than what is typical for an animal of our body size, where the average brain-to-body ratio is 1. So this exceptionally high value has always been assumed to represent a wide gulf between humans and other animals. But I found out 2 important things. First, I found that there are several dolphin species where brains close to 5 times larger than typical and significantly larger in relative size than even our closest relatives, the great apes. This means that the primate lineage is not the only lineage that has evolved oversized, elaborated brains, and that the gap in level of brain development between ourselves and the other animals is just not as wide as we once thought. Second, I learned that it is only in the past 500,000 years to 1 million years that our genus, Homo, has had the largest relative brain size on the planet. Prior to that time, it was the dolphins who had the highest relative brain size. This finding forces us to acknowledge that in a blink of an evolutionary eye, the blink of an evolutionary eye is all that stands between our place as the brainiest species on the planet and our position as just another mammal species with a brain size well within the range found in other mammals. These findings and others I've made with my colleagues and others through the years have important implications for the Fi term in the Drake equation. So, does the big, complex dolphin brain also afford them the high-level capacities we consider to be characteristically human? We know that almost on a weekly basis, we discover that what we thought were unique traits of human intelligence, problem solving, strategizing, planning for the future, imagination, perspective taking, culture, the ability to use symbols, and even do mathematics, are shared by many other species. But there is one fundamental aspect of our minds that we have held onto as being entirely unique to humans, and that is self-awareness. Self-awareness is the fact that each of us here has an ongoing experience of self through time. It's what leads you to look in a mirror in the morning and say, hey, that's me. Well, you might not actually say it, but you're thinking it. Mirror self-recognition is considered a prime indication of self-awareness. Even humans don't get to recognize themselves in mirrors until they're about 2. But in 1970, Gordon Gallup showed that chimpanzees recognize themselves in mirrors. So what about other animals who are not like chimpanzees, our closest relative? In 2001, Diana Reese and I published the first evidence of mirror self-recognition in a non-primate, 2 bottlenose dolphins. Dolphins and primates haven't shared a common ancestor for close to 100 million years. Here's one of the dolphins, Presley, who's in the original study, looking at himself in a mirror after we put a mark on the side of his head. He looks in the mirror and then uses it to try to figure out what that thing on the side of his head is. Take a look. This shows a remarkable convergence of mind and species, separated by so much time, and having taken 2 different neurological pathways to high-level awareness. Of course, we now know that elephants and magpies can recognize themselves in mirrors. But what the mirror studies tell us is that even the most seemingly exalted ability, like having a sense of self, is not unique to humans. The argument has been made that intelligence has emerged only once in the history of Earth. But this is a bias based on our psychological drive as humans to see ourselves as unique, as the pinnacle of evolution. This is called human exceptionalism. But are we something qualitatively different from the other animals? From an astrobiological perspective, we are not, despite all of our capabilities. The science tells us that human intelligence did not arise in a vacuum. It is just a variation on a theme that actually began with the emergence of mobile organisms on this planet about 3.5 billion years ago. Besides my own work and that of others, neurobiological studies have failed to turn up a single property of the human brain that is qualitatively different from that of other species. And I rejoice in that conclusion because it tells me we have a promising path forward in our studies of the evolution of intelligence and mind. We can only understand how human brains evolved in the context of all the other brains on this planet. And we see that Earth is teeming with intelligent life. And it is imperative that we acknowledge the intelligence of other species, because if we cannot recognize intelligence on Earth, how are we going to recognize it on another planet? Excuse me. The search for extraterrestrial life forces us to consider who and what we are in the universe. Likewise, the study of intelligence on Earth tells us who we are among the animals. We can't understand who we are without understanding our relationship to the other animals. But studying intelligence in other animals is laden with ethical concerns. We cannot separate what we know about their brains and their behavior and intelligence from how we obtain that information and what we do with that knowledge. In an astrobiological context, how we behave towards life on other planets will be a reflection of how we treat life on this planet. I think it would elevate our species if the community of scientists seeking extraterrestrial life was also engaged in promoting compassion and respect for the intelligences on this planet. I end with a favorite quote from anthropologist Lauren Isley that I hope serves as a guidepost for future astrobiology and SETI projects. It says, "One does not meet oneself until one catches the reflection from an eye other than human." Thank you.
was wonderful. Well, before we turn things over to our final presenter, we're going to run through the thank yous a little bit faster than we had planned because we are running over. So we'll shorten our thanks, but it doesn't mean that we're curtailing our gratitude. So thank you to everyone for coming out today, tonight, and to the Computer History Museum, to our sponsors, and to the caterers, catered to, because you'd be pretty cranky right now if you hadn't had dinner. And before I announce the next speaker, do you want to just say something about what happens afterward? We have one more.
Yeah, no, I just wanted to thank all of you, actually, for coming here, because, you know, it's not that you demonstrate bravery, or it's not even that you demonstrate tolerance, but what you've demonstrated is an interest in those questions that only humans can ask. I don't know, maybe Laurie's going to contradict me on that, but questions only humans can ask, and only this generation has the capability of answering. And I thank you all for coming.
And further, after the ceremony ends, we invite you to grab some coffee in the lobby on your way out. And if you haven't already, peruse the tables, the SETI Institute tables and the merch tables. Well, we have a final voice whose words will close out our evening. And I'm personally pleased to introduce science journalist Nadia Drake. Nadia was one of my students when I taught radio and podcast production at the University of California, Santa Cruz Science Communication programs. And are you allowed to say you had a favorite student? As well as having a PhD in genetics, she is an exemplary journalist covering, among other things, space science. She is a member of the SETI Institute's board of directors, and she is the daughter of Frank Drake. So it is only fitting that we conclude an evening held in his honor by turning things over to her. Please welcome Nadia Drake.
Good evening, everybody. Lori, your gentle, compassionate studies of cetacean intelligence embody so much of what Dad valued the most, which is curiosity and respect for our planet, for its creatures, and for each other. About a year before he died, Dad and I were at home in Santa Cruz outside, listening to the forest go to sleep. We were listening to the birds turn it off for the evening. And he was particularly excited about watching the bats as they emerged and started looping overhead, using a type of navigation that's almost completely alien to most people on this planet. And as the sky darkened and the bats came out, Dad started sharing what was on his mind that night. And that was kindness and altruism. This idea that we do kind things for one another even when it's hard. Because in his view, it's just the right thing to do. And Dad thought altruism was a key characteristic of the human species, and he relished the kindness that he and his colleagues had shown one another through their careers as they struggled to find an answer to a question that would enrich not only their lives, but perhaps that of an entire civilization. And so I was thinking about that evening with Dad and the birds and the bats and his musings about kindness and altruism in the context of this question that we're trying to answer, which is, are we alone? And of course, the answer is no, not at all. We live on a planet that is absolutely stuffed with life, right? A world that is unique and precious, no matter how common we find out that other Earths may be. On Earth, we are not alone. As Lori said, we are surrounded by remarkable intelligences. But to find out whether Earth itself is alone means that we need to work together in science, as a civilization, and as stewards of our planet, as responsible stewards of our planet, who are also compassionate. And I think we all want to get there. So Dad used to close out the Drake Awards ceremony by sharing some of his thoughts and reflections. And tonight, we are going to reinstate that tradition and give him a chance to leave you with a final word. And he's going to tell you about a time when he thought that he had actually detected a real alien signal and what that meant to him. So as you head home tonight, I hope that you will reflect on that moment that Dad describes and think about what it would mean for you personally to know that we live in a biological universe and that life in the cosmos could be just as rich and unruly as it is in our backyards. So thank you all for sharing this evening with us tonight, and good night.
Wow. This looks like a signal that was transmitted on the hydrogen frequency from the Pleiades, and it's arriving on Earth on this somewhat different frequency because the Pleiades happens to be moving at high speed with respect to us. And so I thought, I've discovered a signal from the Pleiades. This, by the way, was the thing that kept me, that I never left my mind in the years that came afterwards until it led me to try this experiment for real at Green Bank. And when you see that and you think you're sure you have detected another civilization, you feel a very special emotion. It is different from all other emotions, so I can't really describe it to you. But it's an emotion of elation in a sense that you are now part of some much greater world of knowledge and activity, and you have sort of gone through a door into a world of new facts, phenomena, creatures that populate our universe. It's a very powerful emotion because you sense that what you're seeing is going to change all of history, and I think for the better.